Here we go, day 7 of me solving an algorithm per day, and today's algorithm is Day of the Programmer. Mary invented a time machine and wants to test it by time traveling to visit Russia on the Day of Programmer, 256th day of the year. During a year in the inclusive range from 1700 to 2700. From 1700 to 1917, Russia's official calendar was the Julian calendar. Since 1919, they used the Gregorian calendar system. The transition from the Julian to Gregorian calendar system occurred in 1918, when the next day after January 31st was February 14th. This means that 1918 February 14th was the 32nd day of the year in Russia, opposed to 45, right? 31 plus 14. Okay, in both calendar systems, February is the only month with a variable amount of days. It has 29 days during a leap year and 28 days during all the other years. So this means that we don't care about any year, but 1918, we're skipping 13 days because instead of the 1st of February, we have 13 days later, 14th of February. And in both calendar systems, there's leap year. So in the Julian calendar, leap years are divisible by 4. In the Gregorian calendar, leap years are either of the following: divisible by 400 or divisible by 4 and not divisible by 100. Okay, so then for before 18, we're dividing by 4 and see if that's a leap year, and after 18, we are dividing by 400 or 4, and it shouldn't be possible by 100 then, which basically makes the same. Okay, and that's it, I guess. Alrighty, let's get to it. Okay, we have the day of programmer 256, and I guess we can say month list, and starting at January, February, March, April, May, June, July, August, September, October, November, December. And now we want to have days to add a var which is 0, and if the year is equal to 1918, days to add is going to be 13, correct? Because then we're skipping, and then we have leap year before and after, where we want to add one additional day for the 28th of February to 29th. So that means if year is smaller than 1918 and year is divisible by 4, we are days to add is equal, or just increased by 1. And then we have, if year is, actually we can say else if, because then it's obvious it's above 1918. Now if the year is divisible by 4, right? Divisible by 4, no, by 400. Or, and then a whole thing, year divisible by 4 and year not divisible by 100, correct? Year divisible by 4 and year divisible by 100, like that. Then we want to do the same. to add one day. Month sum equals 0. We could say for month in month list, if month sum plus month is smaller than day of programmer, if it's smaller, if the addition would end up being smaller, we want to add to month sum. And if it's bigger, we don't want to add, because then we're basically past our day of programmer. I think we could say month sum starts at days to add, because this is the day. Those are the days we want to skip further. Okay, we can say that, and now we can say else break. I think that saves us just like 2 or 3 loops. Now we have the sum, and we can say let leftover days equals, so day of programmer minus month sum should give us the leftover days. Now we are having we're maybe at month 8 in the sum. We don't know that, so how many month 0, whenever we do add a month, how many month increased by 1. So we know how many months we have, say 8, and then we have leftover days of 13 or 12, if you will. That will mean we are not in month 8 but in month 9, so we have to add 1 into the how many month plus 1 is the actual month, if you will. And now we can say what if this is the actual month is 9. We want a leading 0 months, let's say day 2, string format percentage 2 digit for leftover days, and leading 0 month for actual month. And then we can say we are returning a string with leading 0. We can return a string with leading 0 month and year. Okay, let's try. Okay, our local test cases worked. Now the remote test cases. Sometimes there's also like, if it takes so long, sometimes it just failed and it won't tell you, and then I have to minimize and something happens, so it just, yeah, there we go. It failed for one answer, 1918. It failed for 1918. Okay, let's think about a different solution here. So we have basically down here it already says this is 1, 2, 3, 4, 5, 6, 7, 8 months is August, and then whatever is left is 13. So what we want to do is, okay, so then we know, for example, let until August is 243, correct? So then this is until August, that's not leap year and it's not 1918. So this is like 31, 2, 3, 4, 5, 6, 7, 8. Okay, that's that. And now what we can do is we can say until August plus 14, and down here +1 on leap years, we can remove all that, and we can say we are always in month 9, so we don't care about this. Month's sum would be until August. Actual month is basically 9, and then we're saving the loop. We can remove this one for now. Let's run it. It's still working, and we don't have a loop. Okay, let's try and print just for, you know, in case year is 1918, print the result. Let's run this one again. Okay, and then submit the code. Okay, trick 17. It's running definitely too long. Something is off. So what if that one is indeed like it's 13? Just because it makes sense, doesn't it? Let's try this one again. Maybe that one was the cause why it was loading so long. Local test will always succeed because we are just right for 1800, 2016 and 2017. It's about the other test cases. It's about them. Okay, 1 second. What if we have 243 and then we're adding, that's 250. We're not adding, we're removing until August, like this. And then submit for remote. I feel like the test cases remote, they don't come to an end because I have this print statement in there. Trick 17. What do we have? Congratulations, it worked. Okay, that was okay. That was the algorithm for today. We made it. We had to apply some tricks. I hope you liked today's algorithm, and in case you did, you can hit like or leave a comment in the comment section. It helps a lot. I like to interact with you guys, and see you then.